Hey guys, welcome to Unit 3, Lesson 2. Today we're going to be talking about the quadratic formula and the discriminant. Now the quadratic formula is that special formula that you've probably heard before. Well, you have heard it before back in Algebra 1. And it is x equals negative b plus or minus the square root b squared minus 4ac all over 2 times a. Okay, it's just one of those really weird formulas, but what we use it for is actually to solve quadratic equations. Okay, and it's going to give us two different answers for most cases. And then we have what is called the discriminant. The discriminant is what is under the radical. So in this case, it is b squared minus 4ac. So it's everything under the square root right here. And the discriminant tells us how many answers we're going to have. Okay, so if b squared minus 4ac equals a positive number, then we are going to have two real solutions. And when we say real solutions, now remember we were talking about complex numbers that have imaginary numbers, so those would be imaginary solutions. So the next part would be, if b squared is negative, then we would have two imaginary solutions. And then if b squared minus 4ac equals 0. Now, I should have mentioned this earlier, but the reason we have two solutions is because of this plus or minus sign up here. Remember that the plus or minus means we'll have one answer where we add and one answer where we subtract from the whatever we get in the discriminant part. But if it's 0, plus or minus the square root of 0 is going to be the exact same thing both times. So then it's just going to be one real solution, because taking the square root of 0 just gives us 0. So that would be a real answer. Okay, so these are the three different types of scenarios that we have. All right, let's actually try this out here in example 1. So the first thing is we want to get this in standard form. So for all quadratics, you want to get it in the form of, I'll write it up here, ax squared plus bx plus c equals 0. So we want to set it equal to 0, so we want to move everything to the left side. A is the coefficient of our quadratic term, the x squared. B is the coefficient of the linear term, which is just x, and then c is always our constant. So to get 1 to the other side, I got to subtract by 1. So we get x squared plus 3x minus 1 equals 0. Okay, now I actually have to plug this into the quadratic formula, so that's right up there. But it wants us to use the discriminant part first, so that's the b squared minus 4ac. I'm not going to do this on every single problem. I just want to do it on a couple to show you the types of solutions that we should get. So b in this case would be 3, because that's the single x term. So it's going to be 3 squared minus 4. The a value is 1, because there's nothing in front of x squared, so we assume there's a 1. And then the b value is negative 1. So we get 9. And then these two, negative 4 and negative 1, is going to give us positive 4. So we're going to get 9 plus 4, which is 13. Okay, now 13 is a positive number, so we end up with this situation right here where we're going to get two real solutions. So to solve, we get x equals, and then negative b, so I'm going to plug this into the formula. If you got to go back up there to look at it. So negative b would be minus 3 plus or minus the square root. And we already did the b squared minus 4ac part. That's what we did right here. So I know that this is going to reduce down to 13. And then over 2 times our a value is 1. Okay, so the x-intercepts are, you can actually leave it in this form. Negative 3 plus or minus the square root of 13 all over 2. And if we type that into our calculator, so let me pull this up here. I'm going to bring up the calculator. So if I were to type in -3, we'll just do plus the square root of 13. I have to hit second, square root 13. I'm going to hit enter. I get that, and I'm going to divide that by 2. And it's about 0.3, which if I were to graph that, because remember, we're looking for x-intercepts, so that's a solution. Okay, so that's where it would touch the x-axis. So if this was, let's say that's 1 unit out, 0.3 would be about right there. And then the other side of it, if I were to type in -3 and then subtract the square root of 13 and divide it by 2, I get -3.3. So that's going to be somewhere off to the side here. So this would look something like this. And remember, quadratics are just parabolas. So if we were to graph it, it would look something along those lines, but it would go through the x-intercepts right here. You don't have to type those out and put those in your calculator. I just kind of wanted to show you what that would look like. Okay, let's go ahead and do the next one here. Find the number of solutions by using the discriminant and solve using the quadratic formula. Okay, so for this one, I'll do the discriminant process one more time. So remember, it's b squared minus 4ac. So this is our b, this is our a, and this is our c. A, b, c. So b squared is going to be 2 squared minus 4 times -1 times another -1. So we get 4. And then 3 negatives is actually going to end up with -4 when you multiply all of these out right here. So we get 0. So the discriminant is 0, which means we only have, if we go back up here to our list, 1 real solution. Okay, so if I plug this in, I get -b is -2 plus or minus the square root of 0 all over 2 times -1, because our a value is -1. Okay, then when we simplify, the square root of 0 just goes away and we get -2 over -2, which equals 1. So our answer is x equals 1. But now if I were to graph this, it's still a parabola. It just touches once. Okay, so right here, it would touch a single point at x equals 1. All right, we got a few more here. Now this is an interesting one because if you look at it, it's 0 equals x squared plus 3. We're missing that middle term. So whenever we're missing that, we just assume that we're going to replace the coefficient. This is the same thing as 0 equals x squared plus 0x plus 3. We can still fill in the middle term with just a 0 there. Okay, so if I do the discriminant again, it would be 0 squared, that's my b, minus 4ac is 1 times 3. So we get -12. So -12 is what's going to end up going inside of that. And since it's a negative number, we're going to get 2 imaginary solutions for this one. All right, so if I plug into the formula, I get -0 plus or minus the square root of -12 all over 2 times 1. Now, the square root of -12, I'm going to do that off to the side here. It's the same thing as the square root of 12 times the square root of -1. So we got to break up 12. We can do 4 and 3. 4 breaks up to 2 and 2. So we got a pair right there. So when we simplify this, we can pull it out as 2. We still have the square root of 3 left inside. But since I have that square root of -1, I have to bring that out as I. So it's 2i times the square root of 3. So our answer ends up being x equals plus or minus 2i square root of 3 all over 2, which reduces to plus or minus I squared of 3, because our 2's would technically go away. Now, if it's imaginary like this, it's actually going to be above. It's not actually going to touch our x-axis. That's why it's imaginary, because there's no solution that we can see on the x-axis. Okay, now we have the last one here. And for this one, we want to get everything on one side, put it in standard form. So I'm going to add x and subtract 8 to both sides. So we get 5x squared plus x plus 1 equals 0. 9 minus 8 gives us 1. Okay, so discriminant part, b squared minus 4ac is going to be 1 squared minus 4 times 5 times 1. So we get 1 minus 20, which equals negative 19. So we get another negative number, which tells us we're going to have an imaginary solution. So then I get x equals negative 1 plus or minus the square root of negative 19 all over 2 times 5. Okay, so the square root of 19, that's not going to break down other than the fact that we can pull an I out because it's a negative number. So it ends up being negative 1 plus or minus I square root of 19 over 2 times 5 is 10. So those are the solutions. That's a pretty ugly solution. And we can't simplify anything there, so you can just leave your answer like this. One other thing I just wanted to say, technically we could write this answer another way. We could divide the 10 into both parts. So we could say x equals negative 1 over 10 plus or minus I square root of 19 over 10. That's technically the standard form because it's a complex number that we're writing, but I would accept either one here. Okay, so you have the student problems. Do the same thing. Solve for the discriminant first and then use the quadratic formula. You might have to use the quadratic formula just by going up here and memorizing it. It's something you should be familiar with, and that's why I didn't really reflect back on it too much. But you can definitely go back and forth and keep writing it on the side of every problem if that helps. Okay, do those student